Good morning or good afternoon to everybody. Welcome to our webinar Face Identification with Highscore. This webinar is about qualitative face identification with the Highscore software. Knowing the faces in your sample is usually the first step of an analysis. Often this process is called search match 2, as searching and matching are the most important steps during face identification. A face here means a single, homogeneous, crystalline substance with a characteristic diffraction pattern, usually measured on an X-ray powder diffractometer. Here is a diffractogram of a single face. You see the measured scan in red and the background line in olive color. The high-intensity peaks of the scan are characteristic for this face. The detected peak positions are indicated by the lines on top of the diagram. And here is a diffractogram of a phase mixture. This is the sum of the characteristic patterns of three different crystalline phases. You cannot easily tell which peak belongs to which phase from this picture. Also, peaks from different phases can partially or fully overlap each other. The peaks at higher 2 theta angles are split into doublets because here a doublet wavelength is used. They count as one peak for phase identification. Face identification works by comparison, just like a fingerprint. But unlike a single fingerprint, you often have a mixture of crystalline phases in your sample. To identify the individual phases from such a mixture is far more complicated than just finding one single pure phase. Data must be reduced to a searchable format first. Fingerprints are described by arches, loops, whorls, and more secondary elements. And diffractograms? Diffractograms are described by d-values and relative peak heights. An experimental scan of a pure phase is condensed into a table of d-values and relative intensity. From the d-values and the used wavelength, the actual diffraction angles to theta are calculated easily. Chemistry information and the name are required too. This is an example of the first handwritten reference card from the ICDD archive. Later, quality indicators, subfiles, and much more information was added, and the card filing system changed into an electronic database. Here is an overview of reference databases for XRD face identification. Both commercial and free databases exist. Database quality and database price go hand in hand usually. Next to search match data, some databases also contain crystal structure information, and nowadays even the original scan data. The other databases shown at the bottom of the page are not suited for search match. They contain only crystal structure information and are used for result quantifications. When you work with new substances not yet described in the literature, then you are forced to create your own user reference database. The database manager under the Customize menu is the central point in Highscore where you select your databases. Some commercial databases can be used next to each other. Others can only be used exclusively in one search match run. You select your databases with a check mark under the Use column. An overview of a selected database is available under the Properties button. Commercial databases are in different formats, not always efficient. The Highscore database format offers the fastest possible access to all reference databases. You need to perform a database conversion only once for a commercial release version. Licenses are checked frequently in converted databases, so conversion does not circumvent any licensing. The COD and the Panalytical databases are already in Highscore format and must not be converted. You convert the actual databases in the Database Manager with the Convert button for the selected database. Old legacy databases must be converted with the external tool RefDB Conversion Exe. Here are some more tips. The original commercial database must remain installed. Conversion can take up to a couple of hours. Put the converted database into a data partition of the hard disk, not where the software is stored. And put the converted reference database onto a USB 2 or 3 memory stick or onto a solid-state disk for extra fast response. Basically, there are two ways to fill a user reference database with patterns. Either manually from the existing peak list, these are your experimental reference patterns, or automatically by converting all crystallographic information files in a folder which contains single crystal structure information to reference patterns. The second option is not possible for SIFs from commercial databases like CCD or the ICDD. Please look into the help system for more details on this subject. Okay, now we have everything in place for a face identification, a measured scan with unknown faces, and an active reference database to search in. And Highscore will do all the work. Well, first we need to understand how searching and matching works. And this is determined mainly by the search match parameters. The most important search match parameter is the data source. The data source determines the search match method and which data is used for searching and matching. So we could use peak data only. This is the old-fashioned way of working. It works very well on obvious peaks and is a very selective method. Or we could use profile data only. This is the modern way to perform search match. All intensity above the background is used. A peak search is not necessary. This works well on small and overlapping features, but is not very selective. In Highscore, you can use profile and peak data together. This combines both previous methods and is the best of two worlds. It requires peak detection of significant peaks only, and it works well on high and low peaks and on overlap peaks or features as well. We can easily switch between scoring methods and directly compare the results in the following simple example. Here are the steps for our first live example. This slide summarizes the next steps you are going to see on screen. This is the face mixture scan we have seen already. We will run the default batch, which determines the background line and peak positions automatically. Then we go to the search method settings. We check on the three tabs if the settings fit to our sample. We will now start searching through the whole ICDD PDF4 Plus reference database. And the result of the search is the 400 best matching references. They are listed in the candidates list. And the candidates are sorted by score, which depends on data source selection and more search match settings. The higher the score, the better the match between references and detected peaks or features. And this is how the software was named. There is much more information in the candidates list. Next to the score and the names of each reference pattern, you should look at its scale factor too. The higher the scale factor, the more of the reference pattern intensity is contained in the actual scan data. So major phases have a higher scale factor than minor phases. The other indicated columns tell you how many lines of the reference match the peaks and/or the features in your scan. ML is the number of matching lines of the reference. TL is the number of all lines of the reference. SL is the number of strong, not matching lines of the reference. And NML is the number of new matching lines, which I will explain in a minute. Highscore offers you more details on candidates and accepted patterns. Right-click any candidate to open the Analyze Pattern Lines view. It shows you the status, matched or unmatched, for each individual reference line. Lines at higher to theta angles are unmatched because they are outside the scan range. Right-click to open the Find dialog and to search for a specific name or string in the candidates list. You want to see the whole reference pattern information? Just double-click it. Reference information starts with number, name and formula. Then we have the crystallographic information shown. Subfiles and quality marks follow. Then we have comments and references. Here is the lines list with 2 theta values, d values, and relative intensities. Finally, we have structure data and a display of the lines. Up to now, we have generated a list of the most likely and best fitting candidates, ordered by their scores. The topmost part of the list is filled with many entries of the same references. They are not 100% the same, but very similar indeed. So it's difficult to get an overview, and you must scroll down to find other candidates. Auto residue scoring is the second search match parameter and a very powerful feature. As soon as a candidate is accepted, all scores are recalculated based on the remaining not yet explained peaks and profile features. Now, these candidates score best that do explain the yet unexplained remainder. This puts new best matching candidates on top of the list and pushes candidates similar to already accepted references down the list. Let's go on with our example. We will accept the topmost candidate pattern by dragging it from the candidates list to the pattern list above. Which candidate to accept first is your decision. Watch the rescoring of the candidates below and how new different candidates appear on top of the candidates list. Okay, we will drag the accepted reference back into the candidates list. See how new chromium oxide patterns dominate the topmost part of the candidates list. Again. Now we will accept the first pattern again, dragging it to the top. Also notice that the new number of matching lines is now different from the matching lines number in the candidates list. Let us repeat the accepting step for the next topmost candidate, and once more for the following topmost candidate. We have now identified our three-phase mixture manually with 3 references. The scores of the remaining candidates are much lower now. We have already seen the search match parameters data source and auto residue. I use combined data, peaks and profile together most of the time, but sometimes I switch to peaks only for major phases. I leave the auto residue scoring on all the time. I never change it. The scoring scheme is multi-phase by default. I only switch to single phase when I know or suspect to deal with a single phase. Single phase scoring promotes candidates which explain all remaining peaks and features together. Demote unmatched strong. This is a negative filter, demoting candidates with unmatched strong lines. A strong line is a line with above 50% relative intensity. I leave this on for majors and minors. I switch it off when I expect a very strong preferred orientation being present or when the scan range does not fit to the sample. Then we have matched intensity. On, it includes the relative intensity match of a reference in the overall score. Strong reference lines must fit to strong peaks and weak reference lines must fit to weak peaks or features. Off, only line positions are compared and scored. I leave it on for major phases, but switch it off when looking for minor and spurious phases. You should switch off match intensity as well when you suspect a strong preferred orientation being present in your sample. The next search match parameters are allow pattern shift and known to theta shift. Watch out, these settings often give unexpected results. A known to theta shift is meant for misaligned instruments, which are a thing of the past with prefix optics and good diffractometer maintenance. Allow pattern shift allows for extra large pattern shifts and often results in matching references which have significantly different d values. Note that small pattern shifts are taken into account anyway. I never use these two settings and keep them off and empty all the time. An extra large pattern shift could help in case of strong solid solution effects in phases with a highly variable chemistry. Now we have seen almost all search match parameters. All search match parameters are conveniently available on the pattern toolbar as well. Here we can change most of the parameters and observe the changes in scores, scale factors, etc. instantly in the candidates list. Track graphics range is an interactive setting only available via the pattern toolbar. It restricts scoring to the visible zoomed-in range. This recalculates the scores on the fly as soon as you change the zoom range. It can help to find matches for a certain scan range exclusively. I use it occasionally. Here are some more practical tips. Track graphics range is computing intensive, so you better switch it off after use. The length of the candidates and of the reference pattern lists can be changed under Customize Program Settings Reference Patterns, but making the list longer will slow down search match considerably. Changing the search match parameters only resorts the existing candidates list. New, different candidates require a new search step with different parameters or new restrictions. This takes time and is only done on command. After converting reference patterns to phases for a retrieval quantification, remove candidates and accepted reference patterns to speed up Highscore. Very often you have additional knowledge about the sample to be analyzed, where it comes from, what it is supposed to be, how it was made, if it occurs in nature, and more. The best thing to optimize your phase analysis is to use this knowledge by applying restrictions. Restrictions are filters excluding certain reference patterns during search match. They only allow the specified references to enter the candidates list. You edit a restriction parameter set on the top of the search match parameters. The red flag is a reminder that restrictions are being used in the next search match. Very often you have additional knowledge about a sample to be analyzed, where it originates from, what it is supposed to be, how it was made, if it occurs in nature, and more. The best thing to optimize your phase analysis is to use this knowledge by restrictions. Restrictions are filters excluding certain reference patterns during search match. They only allow the specified references to enter the candidates list. You edit a restriction parameter set on its top of the search match parameters. The red flag reminds you that restrictions will be used in the next search match run. Subfiles are a predefined category in a reference database. Subfiles are groups of references with something in common, like for instance inorganic phases or organic phases, minerals, metallic phases and metals, and more. I use the minerals subfile quite often because most minerals are very well characterized and therefore are easy to identify. Additionally, most minerals are stable under ambient conditions and they are generated by some industrial processes too. Chemistry restrictions are based on chemical elements. Define your own combinations, either as a text or in a periodic table, in the following way. All of means all selected elements must be present together. At least one of means one or more selected elements must be present. None of means all selected elements must be absent. And unselected elements can be either present or absent. Chemistry restrictions are used a lot generally speaking, and are the most selective restrictions I can think of. In version 4 of Highscore you can also read in a report file from an XRF analysis and automatically build elemental restrictions from it. Let us build a chemical restriction set where silicon and oxygen must be present together. One element from sodium, potassium, calcium or aluminum must be present at least. All other elements not mentioned must be absent. Note the instant feedback on the number of references passing the filter at the bottom. The periodic table gives you an overview on all elemental selections. You can also edit elements in the periodic table as well. As a geologist, you might have noticed that we limit the search to feldspars here, a group of rock-forming minerals. Restrictions by quality are based on predefined criteria. Next to real quality indicators, you will find here other criteria to exclude references without an RAR value or patterns collected at non-ambient temperature or pressure. I rely on skip patterns without structure very often because I want to do a subsequent read-width analysis, and I use skip patterns at non-ambient pressure or temperature very often. When you select multiple restrictions on several tabs, then they are always combined with AND. So all different criteria must be fulfilled together. Only when you select multiple subfiles, then they are combined with OR by default. Other possible restrictions are on crystallographic data or on text fields, but they are not used frequently. On the other hand, these are very important for pattern retrieval. Pattern retrieval means to find and directly load reference patterns from a database into the pattern list in Highscore. The same filters as for restrictions are available, depending on the active database, like subfiles, quality, chemistry, and so on. Another possibility is to enter a reference number directly and to load this pattern. Pattern retrieval by strings. This is a text search for text elements in various descriptive fields of a reference pattern. Enter any part of a text and you see the number of the resulting hits immediately. The More button shows an overview on the first 100 matches of each category. For an exact match, the entered string must exactly match the complete string of the reference. Note that existing reference patterns are never deleted automatically. When patterns are present and you load or identify more patterns, then the combine dialog is shown. You have to decide how to combine existing and new patterns. Often I'm asked how to perform face identification in difficult cases. Well, there is no general recipe because each sample is different. The best advice I can give is to use restrictions and use all your knowledge about the sample, like color, odor, origin, and more. And then practice. There are more than 30 face identification examples in the tutorial with the correct answers, starting from very simple to rather difficult cases. Working through all of them will also show you more tips on how to use Highscore efficiently. I often start with an unrestricted automatic batch like ideal, but I make sure the automatic result is correct by inspecting it carefully. Then I try to identify more patterns from the first candidate list by changing parameters and scores, track range, and more. This is shown in loop 1. When the first candidates list is exhausted, then I start a new search with different parameters, with new restrictions, or even with other databases. This is shown in loop 2. Usually this is enough to crack even a hard nut. After loop 2, you could go on and declare a well-defined identified face to an internal standard, shifting everything else according to it. This could help in case of large sample preparation errors. I only do this as a last resort. Finally, one could also try to exclude all explained peaks from the peak list and start a new search match on the unexplained peaks. But when you are stuck and when it gets difficult, you should also check for obvious errors, like a wrong wavelength default, for instance, when you are using SK input. This is a summary of the following example. We will follow loops 1 and 2 of the identification scheme here. For loop 1, we run the automatic identification batch ideal, check the automatic results, and try to find more matches from the first candidates list. In loop 2, we assemble a new restriction set, change some search match parameters, and then manually accept the two remaining phases from the second candidates list. Here is the scan with obviously many overlapping peaks. The automatic identification match ideal is run now and has automatically identified five phases. Two of them do not contain lead, so we'll remove them manually. Then we are looking for good matching lead-containing phases and immediately find one more phase that we accept manually. Looking further down, no more good matches in the candidates list containing lead, so we will move on. The first candidates list is exhausted, so we now start a second search match run. But this time we look at restrictions and will make a new restriction parameter set. This set will not contain lanthanides and will not contain actinides, and also it will not contain any noble gases. We have to look and search a little bit. We make sure that lead will be present in all candidates. Now we go to the search match parameters. We will not use match intensity scoring, and we will only use peak data for input. Now the new search is started and the new candidates list is generated. From this candidates list it's easy to find two more matching phases at its top. There is one small peak left unexplained at the beginning of the diagram, but I consider this example to be done and finished successfully. Well, and this is the end of our webinar. We have seen data reduction and different reference databases. We touched database conversion and user reference data briefly. Then we discussed all search match parameters and looked at auto-residue scoring. Restrictions and pattern retrieval followed. Finally, we looked at the phase identification scheme and on a difficult example. Phase ID is not an exact science. It is more something like a craft. Practicing helps a lot, and by running through the tutorials you will gain confidence and learn how to use Highscore better and faster. This webinar will be available soon on our website, and registered users can look at it again and even pause it at will when things were a little bit fast now. Thank you all and have a nice day.